So we were doing this problem. We have a system of pulleys and they are connecting blocks A and B. So first, as we said, we need for each coordinate to set a reference line. So here a good idea will be to take, anyway, whatever is the reference line you take, this will not affect your result, okay? So because it will, the difference will be a constant, and when you derive, it will cancel out. So here you can take the ceiling level, or you can take the center of this pulley because it's fixed. So you take a line passing by this center. So now what we have is, for block A, I need a coordinate since it's moving. So this is S of A. Now here you have these two pulleys are moving. How we know that they are moving? First, you have block B is in motion, and block B is attached to the center of pulley D. Okay, so we have that the center of this pulley and B will move together. So if you want here, as we said last time, you can take just a coordinate to the center of this pulley because it will represent the motion of B. So this coordinate, we can call it S of B, okay, since it represents the motion of block B. Now, for pulley C, also pulley C is in motion. Why? Because if we look here, the center of pulley C is attached to the periphery of pulley D, okay? And always you'd look at the center of a pulley to know if it's fixed or moving. And of course, it will rotate, but it will not translate if its center is fixed, okay? So here for the pulley here above, the center of the pulley is attached to the ceiling, which is fixed, so the pulley can only rotate, it cannot translate. However, for pulley C and D, both will rotate and translate because their centers are related to something in motion. D is related to B, and C, the center of C is related to the periphery of pulley D, so it's also moving. Okay? Or you can look at it from the other side. You have here the periphery of C is related to block A, which is in motion. This is why pulley C will move. Okay, so from the two sides, the periphery of pulley C and its center are related to moving objects. Okay, so what we will do now, we will look at, uh, we need a coordinate for pulley C because it's in motion. Okay, so you have here, we will take a coordinate. This is the coordinate of C, okay, S of C. So now you have three coordinates in this problem, S of A, S of B, and S of C, okay? And we want to try to relate the velocities of blocks A and B. So to do this, we use the method that is we express the total length of the chords. Now what is new in this problem is that we have two chords instead of three, okay? So to start with, we will take the first chord which starts from here, okay? For the first chord, first, when we go from this point to this one, we have SA. So we'll put, for the first chord, we have SA plus. Now, as we said before, this part which is over the pulley is a fixed length, but we can simplify it you can add plus constant, and it will be simplified when you do the derivative. Plus constant 1, let's call it, which is here the length of this part here, plus. Now, when you go from this point to this one, what is this length here? When you go from here to here, this length is equal to what?
SC.
SC. So we should add plus SC. Plus. Now, we have, when we go over the periphery here of the pulley, it's also a constant, so we can add plus constant 2. Plus. Now, when we go up, again, from here to here, this is what? This is also SC, okay? So we should add SC another time. So plus SC plus. Now you can also, of course, add this part, but this part is what? This is a constant because it's separating the ceiling, which is fixed, from the datum line, which is passing by the center of the fixed pulley. So this is a constant length, if you call it H, for example, or we can just say plus constant 3 equals to what? Equals to the total length L total of chord 1, which is also a constant. Okay, so in general, we can lump all constants together in one term. Okay, and when we derive, they will be simplified. So if you derive this relation at the end, you get what? You get that SA plus 2SC is equal to a constant. So if I derive it with respect to time, I get that VA plus 2VC equals to 0. In this way, I related velocities of A and C. But my purpose is to relate velocities of A and B. This is why now I should move to the second chord and express its length. Okay? Now, for my second chord, I will start from
دكتور في
let
حالة
me
بالwaiting.
let me clear the drawing so it will be clearer. For the second chord, I have first this length from here to here. This length is equal to what from your figure?
SB minus
SB
SC.
minus SC.
Very good. So it's SB minus SC, SB minus SC for the first part. You have plus a part that is going around the pulley, which is a constant. So plus constant 1. And you have also the distance when we go from here to here. So this distance here is SB. And you can add the constant above. So you have plus SB plus another constant equals to what? The total length of the chord, L total of chord 2. Okay? So also, if you lump all constants together, then you get 2SB plus minus SC equals to a constant. And when you derive this relation, you end up with 2VB equals to VC. And if you remember from the previous equation, what was our previous equation? And 2VC equals to minus VA. Okay, so I can replace VC by what? So VC is equal to minus VA over 2. Okay, and now if I replace N to get a relation with B, I get that. So VB is equal to, if you want, what we want to do is to relate with A. Okay, so we can replace VC by minus VA over 2 here. Okay, so we get that VB is equal to a minus VA over 4. Okay, minus VA over 4. So now they said that B has an upward speed of 2 meters per second, so we want to deduce VA. So VA is minus 4 VB. Okay, now in this problem, because they said B is moving upward, so the velocity of B will be positive or negative. They said that VB is moving upward with a velocity of 2 meters per second. So I will count it as positive or negative. Who will tell me? How is your coordinate SB? your coordinate SB, you choose it downward, okay? Because you choose SB downward, this means that VB is positive when it is down and it is negative when it is up. So since here we have an upward motion of B, then VB with respect to S of B, the coordinate of S of B is negative, okay? Because the coordinate is down while VB is up, okay? So here when you replace VB, you should replace by the algebraic value, okay? So you conclude that VA is equal to -4 times -2 equals to +8, equals to +8, okay? So here it is equal to +8. And we deduce, because it's positive, then we deduce that A will move downward. And this is what we expect. If B will move up, A should move down. Okay? So since VA is positive, so it's moving in the same direction of coordinate as A, which is the downward direction. Any question on this problem? So also, once you find a relation between velocities, you can deduce the relation between accelerations, because if you derive this relation with respect to time, you get the acceleration of A is equal to -4 acceleration of B. Now in this problems, I didn't give anything about the acceleration, so we don't need this relation. But in case they gave us the acceleration of A, we can deduce the acceleration of. And we will learn in the next chapter, we will learn how to find the acceleration using the second law of Newton. Okay? So this is for this part. We still have a last part in this chapter. Try to practice with this problem, okay? So this is the same concept. You have a system of pulleys, and you should correlate the motion of A and B. So try to do it, and if you have any problem, you can ask me whenever you want. Okay. This is another problem. I will do it because it's a little bit complex here. So a man A is holding a safe S by walking to the right with a constant velocity VA equals to 0.5 meters per second. Determine the velocity and acceleration of the safe when it reaches the elevation at E. The rope is 30 meters long and passes over a small pulley at D. So in this problem, we have a block S, and we try to lift it upward, and we do this by moving A in the, so this point is moving in the horizontal direction to lift block S upward, okay? And we want to find if the velocity, knowing the velocity of A, we need to find the velocity and acceleration of S, okay? So we need to relate motion of A and S. To do the relation here, because we have a chord that is relating both, so the idea will be to express the total length of the chord function of the coordinates of A and the coordinates of S. Okay? So first, for coordinate of S, S is moving in the vertical direction. So the coordinate for S is Y. Okay? While A is moving in the horizontal direction. So I will take for A certain reference line, let's say here. Okay? And this is x of A. This is x of A, which represents the coordinate of A. Okay? So we have here, this is x of A, and this is y of S. Y of C or y of S, it doesn't matter because they are moving together. Okay? Now, who can tell me why I didn't choose the coordinate like this, for example? Like this. Can I choose the coordinate like this, inclined? Why I didn't choose the coordinate inclined like this?
Because you can't find the angle.
Because the angle is variable. Very good. Because if I have a variable angle, then my direction is variable. And never work with variable directions here, because if you choose a variable direction, when you derive, you should derive the change of direction also, as we did in UNUT frame. Okay? So here, we cannot take a variable direction. Always choose a direction that is fixed. This is why we take the vertical and horizontal as my directions. Okay? Now, after I choose my directions, the next step is to express the total length of my chord function of y and x. Okay? So, for my chord, I have this part CD plus dA. Okay? So I can write that CD plus dA is a constant. CD plus dA is equal to a constant. Okay. Now I want to express CD and dA function of my variables x and y. So to start with CD, what is the expression of CD function of y? If you look at your figures, I gave you this distance. This is 15. Okay. And to find CD, all I have to do 15 minus what? Minus y. Okay, so I can replace CD by 15 minus y plus, for part dA, how to compute dA? I will use the Pythagoras theorem, because here I have a right angle. So here this is perpendicular. This is a right angle, so I have a right triangle. So from Pythagorean theorem, I can say that dA is simply a radical of this distance from D to the floor, which is fixed, which is 15 meters. So radical of 15 square plus this distance from here to A, which is variable, it's equal to x. So plus x square equals to a constant. Okay. And what will be this constant here? What is this constant in this problem? It's the total length of the chord, and the total length of the chord here is given. And they said that Pulley D is very small. Why they said Pulley D is very small? To neglect this part, the part that is over the pulley. We can neglect it because the Pulley D is so small. So we can say that this is equal to 30. This is equal to 30. Okay. So now all we have to do is to rearrange the terms. Okay. So we can take 15 minus y to the other side and do it square, because when we do it square, it will simplify the form of our equation. Okay. So let us try to do it. If we take 15 minus y to the other side, we get, and so I will directly put the two terms square. Okay. So instead of radical, I will get 15 square plus x square, okay, equals to, when I take 15 minus y to the other side, I will get 15 plus y, okay, and I should put it square since I did also the other term square. So 15 plus y square, okay. Why I did this? Because when I put it in this form, the derivative will be easier, because you know that deriving a radical is not simple. So it's if I put it in this form, it will be easier for me to derive. So now I will derive each side. Okay. If I start by the first side, what is the derivative? If I have x squared and I want to derive with respect to time, I use the chain rule. Okay. So the chain rule will tell me that I derive first with respect to x, then I multiply by dx by dt. So it will give me 2x times dx over dt. This is the chain rule. Okay. Equals to, from the other side, I have a function of y. So to derive with respect to time, I derive first with respect to y, then I multiply by dy by dt. So if I derive first with respect to y this function, I get 2 times 15 plus y, okay? And I multiply by dy over dt to obtain the derivative with respect to time. Now, what is dx by dt? What is dx by dt? It simply represents the velocity of point A, because x is the coordinate of A. So if I derive x with respect to time, I will get the velocity of A. So now here I can write that it's 2x times the velocity of A equals to 2 times 15 plus y, 15 plus y, times dy by dt is the velocity of block S. So it's plus, it's times velocity of, so here, times velocity of block S. Okay? So now what I did, I related the velocities of block A and S. So all I have to do now to find what is the velocity of S when I reach position E. So when I reach position E, what will be the value of, when you reach this position, what is y of S? It's equal to 10. So you replace y by 10. So here, for the position given, I replace y by 10. Okay, and VA is given, it's a constant, it's 0.5. So I replace VA by 0.5. I still only have the value of, to find the value of x. How to find the value of x? Who will tell me? If I give you y, how can you find x? Remember that you related x and y through what? Through the equation of the chord here. This relation will give you a relation between x and y. So if I give you y equal to 10, if you replace in this relation, you can get what is the corresponding value of x. And when you get it, you can just replace it. You can just replace it back in this equation. So the only unknown will be velocity of s, and you can get. Okay. So this is for the velocity part. Now, for the acceleration, if I want to find the acceleration of s, what should I do? All I have to do is to derive the relation of velocities. Okay, so I got that to xva is equal to 2 times 15 plus yvs. All I have to do is to derive the velocity relation to get a relation between accelerations. So let us do it together. You have here x times va, so it's the product of two functions. When you derive the product of two functions, it's u prime v plus v prime u. So what you should put is here, you have 2 times dx by dt, 2 times dx by dt times va. Okay, this is the first, the derivative of the first term, plus 2 times x times the derivative of va with respect to time. Okay. But here in this problem, they said that VA is a constant. Because VA is constant in this problem, so you will dVA by dt will cancel out. But if it was not constant, I should take it into consideration. Okay, so this term here will cancel out because VA is constant. Equals to, from the other side, if I derive this function here, okay, the same procedure. I have the product. If you want, since you have 2 in the two sides, you can simplify 2. So I can simplify 2 from the two sides, and here I don't put it. Okay. So here I will have to derive the product of two functions, 15 plus y times velocity of s. So here, first I derive the first part. The derivative of 15 plus y is dy by dt. So this is equal from the other side to dy over dt. times velocity of s plus, if I derive now the second term, so I have plus 15 plus y plus 15 plus y times dvs by dt times dvs over dt. Okay, and the derivative of vs with respect to time represent what? This is the acceleration of s. Okay, and dy by dt is the velocity of s. So now if I replace, this is equal to dy by dt is equal to velocity of s, and I have times velocity of s, so velocity of s squared plus, from the other side I have plus 15 plus y times acceleration of s. Okay, so this relation gave me what is the acceleration of s, because this is from the other side equal to what? Dx over dt times va, and dx over dt is the velocity of a, so I get it's equal to velocity of a squared. Okay, so now in this relation, the only unknown is acceleration of s, because at any position I can calculate vs from the previous step. I calculated velocity of s, then I replace back in this relation to get acceleration of s, va given to be constant. Okay, any question on this problem? Okay. Now, this is the last part of this chapter, and it's very easy. This is the easiest part, which is relative motion. Okay, so if I have, if I have two moving objects, I can measure the velocity of one object relative to the other. Okay, so in this figure, you can understand this clearly. You can have a fixed observer. If an observer is fixed and is looking at A and B, he will measure their absolute velocity. However, if you have an observer that is translating with a certain frame, and he is looking at the velocity of B, then he will measure a different velocity, which is the velocity of B relative to A. Okay? Now, to correlate absolute velocities and relative velocities, all we have to do is to relate the positions. Okay? So if you look at this simple figure, what can we say? We can say that OA plus AB, OA vector plus AB vector will give us vector OB. Okay, and we can write it as following, because OB we name it RB, which is the position vector of B. So this is RB represents vector OB, which is the vector position of B with respect to the fixed frame. So this is OB vector equals to RA is the position vector of A with respect to the fixed frame. So it's OA plus RB relative to A is vector AB. So it represents the position of B relative not to the fixed frame, but to the translating frame. So you have a frame that is translating and you are on the translating frame, okay, because you are on A. So you will move with A. Since you move with A, you will measure with a velocity that is called relative velocity. Okay, so you can measure the relative velocity of B with respect to you. So from this relation, we can deduce that vector AB, which is RB relative to A, is simply RB minus RA. Okay, and now if we derive this relation with respect to time, if we derive this relation, we get the following. We get that VB equal VA plus V of B relative to A. VB and VA represent the absolute velocities. When I say absolute velocities, I mean that these velocities are measured with respect to a fixed frame. So VB and VA are called absolute velocities. measured with respect to a fixed frame. Okay, and we have that VB relative to A, so this velocity is a relative velocity. It's measured with respect to the translating frame which origin is at A. So this is the relative velocity of B with respect to a translating frame of origin A. You know why I said translating frame? Because if it's not translating, I cannot apply this formula. Why? Because look, when I did the derivative of RB relative to A, I considered that the unit vectors of the frame are not changing. So if a frame is translating, ijk of the frame will not change in direction. So when I derive, I don't have to derive the unit vectors also. So this is why, pay attention, this formula is only applicable if A is on a translating frame. If A is on a rotating frame, for example, I cannot apply it. And you are not responsible of what we should do because it's very complex and it's not included in the program. So this relation is only valid for A on a translating frame. So then I can say that V of B relative to A is VB minus VA, where VB and VA are absolute velocities measured with respect to a fixed frame. And now, if you derive this relation again, you can get a relation between accelerations. The relation between accelerations is that acceleration of B is equal to acceleration of A plus acceleration of B relative to A. Okay? So we will do next time a practice on this part, and in this way we'll be done with the first chapter of dynamics. This is the hardest chapter in dynamics. The two other chapters are very simple and smaller. Okay, so if you understand this chapter well, the two other chapters are very related to it. So they are simple, relatively. Okay, so hopefully we can continue on Friday, and we should do a makeup session because we lost a session on Monday. Okay, so we will agree together on a corresponding timing, maybe for this Saturday. Okay, we will talk on the group about this. Any question before I close the session?
Thank you.
Okay, bye bye.
Thank you, doctor.
Welcome.